Um, yeah, if one of the worlds, if gravity worked only on liquids, then all your blood, or everyone's blood would just go down into the legs. That was one of the answers. Uh,
They also had some. They also had something about circulation. I didn't quite.
yeah, all the blood would go down to the, if it was only, if gravity worked only on liquids
Huh.
in that world, then all the blood in the body would go down into the legs,
Yeah,
the bottom part of the body.
yeah, and the
And
solid
there
parts will
was,
not be affected. Yeah.
and in another world, the solid and liquid would separate. They couldn't be together. So we would be, in in any body, the blood and the solid and liquid would get separated. That was one of the answers.
Yes, but if gravity were to act only upon liquids, then our evolution would have been different.
Yeah.
Yeah,
Of course.
that is exactly the point.
No,
So,
no, this required a face-to-face
Okay,
lengthy
okay,
yeah,
conversation.
yeah.
yeah,
These were answers just on WhatsApp in
Okay.
messages.
yeah.
Yeah.
Chirantan's question was, I don't understand how can, such and such happen if that is the world. And that is precisely the point. In that world, uh, will we be meeting today?
Mhm.
What
If that
if?
were the case,
Yes.
counterfactual, this meeting would not have taken place.
It is very difficult to even like picture how that world would be, right? Like we can say how it would not be, but how it would be, it is very difficult to.
Well, the thing to do is to assume that, except for that, you can, can you assume that there would be an earth to begin with? Or alternatively, you might think deeply about it and say, such a world as we know it at all, stars and galaxies and the earth and so on cannot exist.
Yes.
To begin with, you have to ask the question, at what point did gravity come to exist in the universe? Gravity requires mass, right?
Yes. And two bodies.
Yeah, at least two bodies with mass, which means we need at least things like, something like atoms or at least fundamental particles. Gravity does, we have to ask the question, does gravity affect fundamental particles or only atoms and subsequent things? Anyway, for the liquid to form liquid, you have to have molecules, right?
Yes.
So until that point, perhaps our world would have been the same. And then it branched off into another world. Okay, this looks like I can see smoke coming out of, my computer screen from all the ears of people.
Can I make a point on gravity?
Uh-huh.
I read somewhere that it is the reason why our Earth is circular or a geoid because
Yes.
gravity compresses it equally on most sides of our planet. So, and you just said that if gravity only acted on liquids, then I think our Earth would have been really irregular because of some parts being land and some parts being water.
Possibly. Are you assuming that the Earth is rotating?
I missed out on that.
Yeah. You are assuming two things. One, in this world, the Earth does exist. And number two, in that world, the Earth is rotating. The question would be, would the world exist? Sorry, would the Earth exist in that world?
No, I have a question around counterfactuals that may be observed but interpreted differently. So, counterfactual of an interpretation. So, for example, gravity, let's say I say gravity acts on everything except planes and birds. And that's why birds and planes can fly. Now, that is a counterfactual explanation of an observed phenomena which is true. So, does counterfactual always need to be the observed phenomena isn't true, or that cannot be observed? Or is it just about an explanation of something that is observed?
Yeah,
It's
actually, that's a very important question.
Yes. And but then again, there is the observed thing that, for example, if a bird is shot at and gets shot, it comes to the ground. Why is that? Even though it was flying until then, it comes down. And a plane, if it crashes, comes down. Why? So there are other observations that come into the picture.
Yeah.
There is another strand to Rahul's question.
Mm,
We construct theories speculatively, imagining things,
right.
And imagining things, you are not saying that is not the case. It is not a counterfactual, but it bears some strong similarity with counterfactuals. In fact, in some cases, people may even say it is counterfactual, because you are saying, imagine that the world has multiple dimensions in addition to the normal three dimensions. Or imagine that the world is not Euclidean world, but curved world, and so on.
But anytime you ask something like that, you also you're asking what if, but somehow automatically you're also asking what if not?
Yeah.
So
Dalton asked this question: what if the substances were made of atoms? Aristotle never believed that was the case. Aristotle believed that matter is infinitely divisible, and Democritus and Dalton said, here is another possibility, that the world is made up of atoms, and the process of division must stop with atoms. Atoms are not divisible entities. Now, for Aristotle, that was a counterfactual statement. And there are many things of that kind. If you are committed to a particular theory, some other theory is counterfactual. And the only way for me to engage with the other theory that I reject is to take the counterfactual seriously, look at the consequences. So learning to be a scientist requires the ability to consider the analogs of counterfactual seriously and pursue the consequences, and see if the consequences match what we see, what we observe. And that's not an easy thing to do.
Would the pursuing that scenario with a counterfactual, how does it relate to simulation? So essentially, you're modeling the world according to your world rules, and then you're trying to simulate a counterfactual, although the world is still modeled around your world rules. So modeling counterfactuals in a simulated environment, is that almost an oxymoron? Like, you cannot probably have a counterfactual if you have really modeled the rest of the world to test it under.
Wouldn't that depend upon what you mean by simulation? For example, you could simulate the heliocentric theory, right? Simulation typically implies, in traditional sense, simulation implied constructing a theory, and letting the computer then implement, sorry,
Yeah,
look at the
I was thinking
consequences.
just a bunch of math equations in the computer that just mimic what you think.
Yeah, so there is a theory in any
Yes, there
system,
is a theory implicit in there.
right?
Yes.
So that theory is speculatively arrived at, and maybe tested or not tested, doesn't matter.
Ah,
So you could ask the question, what if words did not have any meanings, but they had some relations on distribution and statistical, rules about the distribution? You can predict the occurrence of, after 3 words, you can predict in probabilistic terms the next word. Okay. And you're denying words have meanings and saying irrelevant whether you have meanings or meanings exist in people's minds. I don't care. Words are the objects in the world. Would that simulate people's behavior?
Yeah, that's a very nice one. In fact, AI works that way, right? It's
Yeah.
predicting based on a word cloud. It doesn't quite understand the meaning.
Yeah.
And incidentally, AI is very bad at counterfactuals.
Yeah.
So, given a maths problem, AI will give you a solution. But given a solution from a child, AI is not good at figuring out the 10 ways in which the solution is wrong
Yeah.
or could go wrong. And I guess, yeah, what you just described is exactly the reason for that. But how do you explain that? So if you say just words without understanding the meaning, if we created something like that, how do you describe such a world where words are just predictions, not
You
don't
can
have
describe
meaning?
the theory fairly easily. For example, you can assume that there exist things like letters, okay? And there are rules governing the letter combinations, and there is a unit called word. Words are simply combinations of letters. And then there are things called phrases, and phrases are combinations of words, and sentences are combinations of phrases. Meaning doesn't enter the picture.
But wouldn't now you say combination of phrases are a concept, and suddenly now you evolve to concepts in this very dry language, but now suddenly you have concepts and your meaning and
Yeah, the moment I say concept,
ah,
then there is a meaning element coming in, but I don't have to say that, right? I
yeah,
can describe all this to computer, right? That is what Chomsky
yeah,
did.
Actually, instead of a concept, you could just say that it's a unit.
yeah, yeah,
That's it.
yeah. So something like everything that is derived out of some Latin root
Yeah.
suddenly is ology, and suddenly everything is related to theory. And anything, any word that's ology, I can say it's related to philosophy and it's related to theory. And it's likely going to be true. So if you take all the ologies as a unit, then I may not know the actual thing, philosophy, but most of the things I would say about philosophy with that would still be true.
True doesn't enter this world, right?
Yes. It would be logically consistent.
Yeah. The
With the
computer
prediction.
will give you the consequences. That's all.
Yeah.
It doesn't care whether it is true or not.
Yeah.
Because truth is a relation between the knower, a human, and the thing that you say you know.
So in counterfactual reasoning, truth does not exist.
Fact doesn't exist in
Fact
AI.
doesn't exist, correct. True.
So it's not, I'm assuming that we are all sitting in a circle and nobody has any special status in the circle. It's a kind of Ubuntu circle. And if you want the conversation to continue sitting at a round table, somebody has to take the initiative.
Mo, should we invite Chirantan to ask the questions he was going to?
Chirantan had a number of extremely
Yes.
interesting questions. Yeah.
Right, so she should ask them now.
Yeah.
Oh, yeah. Sorry, 1 second. I will just find them. I can't recall them. I'll just.
While Chirantan is
So, th-
searching for the questions, just to continue what was being discussed right now. So if we were just going to go by mere probabilities of forms occurring next to one another, then if the world was to end or change radically, still they would continue producing the same forms. In the sense they are not really talking about anything. It's just
Yeah.
joining forms next to one another.
Yeah.
In that sense, AI doesn't know what it is talking about.
That's not very different from what Russell said about mathematics.
Hmm.
I mean, Russell was talking about formal mathematics, not really conceptual mathematics. If you view mathematics as simply expression of symbols and symbol combinations and derivations, then mathematicians don't have to know what they're talking about. Given such and such premises in such and such language, what are the logical consequences? Mathematicians will tell you. But what does it mean? They don't have to know.
Right.
In the formal mathematical idea.
Yes.
But if it is the kind of mathematics that Euclid practiced,
Yes.
there was considerable concepts in it. It wasn't simply algebra without meaning. Geometry has to have the concept of space, the concept of line, the concept of triangle. If you reduce to formal symbols, triangles and circles disappear.
Right.
But even then, wouldn't they have a meaning? I mean, the plus symbol has a meaning, and
Yes.
so it's not. I mean, it's not like there is no meaning there, right? Or
There is no meaning that relates to the world of experience.
Okay.
So, when you say something like x plus y close brackets divided by z, there is a set of operations called multiplication, division, etc. Things are prescribed, which computers can perform without understanding the meaning. The instructions can be performed without understanding the meaning. So in that sense, there's a formal meaning in the sense like what to do when these operations are given. And that is like saying you teach a child how to press the buttons on a pocket calculator. The child doesn't know multiplication addition, but the child can produce results by obeying the instructions correctly. The child can be even better than, a human.
But isn't then the act of creating formalisms for theory the act of removing meaning out of
Yes.
words?
Yes, it is emptying the meaning so that computers can perform these actions
So we're doing all this work so that computers can just take action without knowing the meaning of what we're saying. Formalisms are kind of helping the math solvers and all
That's
of
how
that.
it's used, right? Typically, formalisms, unless you're really careful about it and serious about formalism, you do use formal notation. Actually, it turns into just plain notation rather than a system.
One has to be careful here. I am not denying the importance of formalisms.
Yes.
I'm not an anti-formalist. In fact, if there are anti-formalists, I would persuade them to learn formalisms.
Yeah, formalism is part of a larger process. It's an important part of a larger process, I guess.
Yeah. I had an interesting conversation this morning with John Goldsmith. And I was telling him about the difficulty of communicating across epistemic cultures. So I was talking to a colleague who gave me a paper to read, and I said, this paper I will not accept even as an honors thesis because there's no argument. And it was pointed out to me, but there is. I mean, there is evidence And I said, there is data, but there is no evidence. Data becomes evidence only when it is used in an argument. And I don't see the argument. And if I don't see the argument, there is no data. It just present data, and then there is a conclusion. But what's the connection between the data and the conclusion? And in saying this, I was assuming that every research article must have arguments, and arguments are in the form of premises, conclusions, and steps of derivation from premises to conclusion. Notice this is a very peculiar way of, characterizing academic research. But not all human knowledge can be expressed in this fashion. And my favorite example is this. I'm taking a walk outside, my morning walk, and there are trees and various kinds of things. And suddenly I experience a certain fragrance. And I say, oh, there must be a jasmine plant nearby. Okay. I know that there's a jasmine plant nearby as a cognizer. How did I come to know that? Well, the basis is my experience of some fragrance, which I classified as jasmine flower fragrance, and my prior knowledge says jasmine flowers grow on jasmine plants and only on jasmine plants. Therefore, there must be a jasmine plant nearby. That's a kind of unpacking the inference. But now, if you ask the question, what is jasmine fragrance? Define it. I have no way of doing that, right? I know when I get the fragrance, I know it is jasmine. That's all. Number one problem. Number two, you may have experienced jasmine fragrance and you may agree or disagree with me. Given the same flower that I call jasmine fragrance, you may say, no, that is not jasmine fragrance, because your classification of jasmine fragrance may be different from mine. In fact, we may even look at the plant and I may say that is jasmine and you may say it is not jasmine. So we don't have the same meaning for the word jasmine. And yet we seem to be able to, in spite of having different meanings for different words, we seem to somehow or other agree that the claim is true, or disagree, no, the claim is false. Now,
we miraculously manage to communicate.
Yeah. It's an amazing thing that what we do. In spite of all these terrible things in language, we seem to collectively grow this thing called academic knowledge. How do we do that?
But sorry, go ahead.
Yeah, I was saying the kind of formal system that gradually grew in mathematics and physics, these things did not exist during, 5,000 years ago, let's say. And we have developed these ways of knowing. And one of them is converting human language to these formal symbols so that the question of understanding does not arise. So all of us have the same conclusion.
In which case, what Bolyai and Lobachev did with Euclidean geometry, would that fall under what you're saying? That's one. The second question is, would that, going back to the basics again, just for my understanding, would that be at that point of time when Bolyai and Lobachev postulated whatever they said, would that be counterfactual?
Okay. Now, before I say anything, two things. One, I don't want this to be a two-way conversation. There are some school students here, 8th grade, 9th grade, right? So can you ask that question in such a way that they understand? Otherwise, we are leaving them out.
So if someone could prove or was able to prove that one of Euclid's geometry postulates or axioms need not necessarily be true. I'm hedging my words here. Correct me if I'm wrong. I mean, I was not prepared to do this.
That's okay. That's okay.
Yeah. Then how would... So two parts to it. One is we're learning so much more in mathematics, thinking about things in a different way. That was what prompted this thought, right? So how would this particular example where two people called independently, Bolyai and Lobachev.
Yeah.
They sort of came up with something which showed that
Yeah.
one of Euclid's axioms need not
Yeah.
be necessarily
Yeah.
true. The second is, would what they postulated and came up with, non-Euclidean geometry, would that at that point of time when they did it, would that be counterfactual? I hope
Okay. Let me since I know these particular 8th grade students little more, let me try to articulate it in their language to the extent it is possible for me. Yeah. To the extent yeah. Sorry. Who said that? Okay. Doesn't matter. The only mathematics that school children have learned is Euclidean mathematics. And Euclidean mathematics makes the assumption that two straight lines, when extended, can meet only once, only intersect only at one point. That is the basis, you can say. I mean, there are many ways of formulating Euclidean axioms, but this is one assumption that Euclid makes. Suppose you say two straight lines can meet at two distinct points when extended, and any two straight lines must meet at two distinct points. If I say something like any two straight lines must meet at two distinct points when extended, I said this in English. There is no formalism here at all, no algebraic symbols, English words. And of course, Euclid used Greek words. Now, would an 8th grade student or even a 10th grade student say that is true? It is so, from common sense tells us that is impossible, right? How can two straight lines meet at two distinct points? That is shockingly untrue. Now step back. Why is an 8th grader or 10th grader saying that is impossible? It is not true. Because 8th grader is thinking about geometry on a flat surface. Now ask the 8th grader, 10th grader to imagine not a flat surface, but a spherical surface. Let that happen in the mind. And now ask, do an experiment in that world, in a spherical surface, draw two straight lines. Okay. And check in their mind whether they meet or not in two different points. Of course, you have to be clear about what you mean by straight line. Can straight lines exist in a spherical world is a separate question. So this will take some time. My experience has been it takes a lot of work with imagination before they can imagine the situation. But once they see that, then they can work out the logical consequences. So the first step was, yes, counterfactual from the point of view of the learner. But once the learner becomes comfortable with it, they can ask, what is our world like? I had this idea that our world is flat. But what if our world is not flat? And that is where Einstein comes in and says, our world is not flat. But the mathematician doesn't care whether the world is flat or non-flat. The mathematician is an imaginative person. That mathematician constructs imagined, logically possible imagined worlds and spells out the logical consequences of that world. And in this sense, a mathematician is not very much unlike the person who wrote Harry Potter. Harry Potter is a mythology invented by this novelist. And I haven't read many Harry Potters, but my impression is, suppose somebody said some character in Harry Potter talked to somebody else with a smartphone or type stuff on a computer, would that be strange? Somebody who has read Harry Potter will have to tell me. I'm not sure. My feeling is that will be inconsistent with the world. Such a thing cannot happen in that world.
Yes, it would be inconsistent, seeing that in Harry Potter there are many ways of communication which are not available in the real world.
So that's, yeah, you're saying that is its own, Harry Potter is a separate world itself.
Yes,
and you have strong intuitions about what is possible and what is not possible in that world. Yes. So a mathematician has that ability to construct logically coherent worlds. What the novelist does not do is to prove theorems. But the first step, the novelist and the mathematician are very, very similar.
In that the story has to be consistent.
Yeah.
The world has to be consistent.
But here's a fun fact more. Harry Potter talks about airplanes. It talks about, I mean, at least as far as I can remember, it talks about airplanes, it talks about trains, it talks about a lot of, it is based pretty much in the modern era, but there is no mention of computers.
Yeah, it's a
That's the one thing that's not mentioned. The rest of it is pretty modern, but yeah.
Yeah. And most mythologies are, mythologies have their roots in the real world that we live in, but they change things. And that is true about mathematics as well.
So, Mo, when new theories are invented, right? Somebody created a counterfactual for the straight lines and came up with a non-Euclidean way of doing math. Then someone discovered quantum computers or quantum computing and then figured out in the quantum realm, this is how it works. Now, funnily enough, nobody is cutting out the other guys. Everyone's creating a happy world for themselves. So like, oh yeah, you can live in the Euclidean space. Of course, you can do math in the non-Euclidean space. And quantum realm is completely different, and even that exists. And so, in spite of creating counterfactual arguments, it hasn't debunked the previous theory. Or does it matter only when you start getting to the dangerous boundaries between these two worlds, where it's too much of a sphere and now you're doing all the math on Earth's surface? Now your non-Euclidean starts mattering. If you're in the regular world, 90% of the time you're never going to think non-Euclidean. Similarly, quantum, right? If you go too small, you're thinking atoms, you're thinking really, really small realms, then you will hit quantum. So then to that, can the argument be that there is a special case where the Earth is still flat? It's just that we are living and the observations that we have currently are consistent with the Earth being round. But if you go into a boundary case, which hasn't been defined explicitly yet, Earth is flat theory also would apply, and 20 observations would also be true there.
Yeah, sure, that would be a different world, right? So this is precisely where you cannot mix two worlds. It's always, they work on different principles and different objects, different kinds of objects, and they would have different kinds of mathematics.
See, that it works for limited number of cases is not sufficient to show that it is true. To show that something is true, you have to expand the range of your experience. Take, for example, classical physics of the kind that Archimedes was working on. Archimedes wanted to explain facts of motion when two things are in contact. Let's say two balls, one hits the other. But if there is a ball that is standing there, sitting there, and another ball passes by, there is no effect on that first ball, right? So the general idea at that time was that X can exert force on Y only if X and Y are in contact, not otherwise. Okay. This was the worldview, and that worked very well for a large number of cases. All of Archimedes' machines worked that way. The cannons and water mills, everything, they all worked when the two things were in contact. A sewing machine works that way. You do something with the, what do you call that? The handle of the sewing machine. And there are various pieces which are in contact and various things happen. And then the needle goes up and down. And it's really interesting to work out the sequences from the handle to you turn this way and the needle goes up and down. And that is a mechanism. When scientists say mechanism, they're talking about things which are causally in contact. Now comes Galileo and says that things X can have a causal effect on Y even when they are not in contact. And gravity is precisely that situation. And the sun, Newton said, the sun makes the Earth move around in a circular orbit, even though they are so far apart, because of gravity. So gravity is action at distance. Now, Archimedes would have said that is completely counterfactual. That cannot be the case. So at that point, it is a counterfactual. But once Archimedes accepts Newton's position, it is no longer a counterfactual because Archimedes' knowledge has changed. So fact is dependent upon your assumptions.
So
And then
knowledge
Einstein
has,
comes along and
yeah.
says, no, there is no action at distance because the gravitational field of the sun is in contact with the Earth. So back to no action at distance.
So more, just to build on what Taran you were saying. So would it be possible that, I mean, I won't get into who said this, but would it be possible to have a world where both, I mean, this and this, yes, and say A and B, right? Let's take A and B. It's usually either A or B. In a world, either A will happen or B can happen. But it could be both A and B can happen, or both A and B don't happen, or but does this counterfactual theory mean that it is either A or B, or can it also contain both A and B, neither A nor B, or none of the four tenets?
Yeah. Let me see if I can translate this into the language of the school. I don't know. Many of them are here from school, Kaveri School in Pune. Okay. There were two fundamental principles that Aristotelian logic said as inviolable. One is every proposition is either true or false. There is nothing in between. So there are only two values, true, false, and there is no other value. So if something is not true, then it is false. If something is not false, then it is true. And that allowed us to derive what is currently called proof through contradiction, like Euclid's proof of prime numbers and so on. Aristotle also said another thing, not just there are two values, only two values, but also that logical contradictions are forbidden. It is not the case. Any statement of the form X and not X is false. So it cannot be true and not true. In the first case, it has to be either true or false. The second one says cannot be the case that it is both true and false. Now, this has been the foundation of logic until about 19th century, when logicians challenged the first one. They invented three-valued logics, and we often use three-valued logic in many cases. I'm not going to go into the details of that. But then we all subscribe to the sacredness of the prohibition of logical contradictions. Okay. Sometime, I don't know which year, maybe 8th century or so, maybe even before that. I'm not sure. Now, somebody here would know a logician, Indian logician called Nagarjuna. Does anybody know which century? I'm very bad at centuries and stuff like that. Which century? Postulated a system called Chatushkodi, that is 4 corners, which violated Aristotle's basic axioms. Said it can be there can be situations in which it is either A or B, both A and B, neither A or B, and then both A and B when A and B are logically contradictory. And when I came across this, I said, how can that be? Nagarjuna was an excellent logician. How can he say subscribe to logical, prohibition of logical contradictions. He wasn't saying that logical contradictions can be true. What he was saying was that in one context, something can be true. In another context, it can be false. So you could say in Euclidean geometry, the world of Euclidean geometry, it is true that the sum of angles is 2 right angles. But in spherical geometry, that is false. So you cannot, you can say that, yes, they're both true in 2 different worlds. And that was essentially the idea that quantum mechanics, I don't think quantum mechanics borrowed from Nagarjuna, but essentially it is what is called tetralemma, tetra means 4, that you find in quantum logic. So the issue is, until 19th century, that statement was counterfactual. But in 20th century, 21st century, it is not a counterfactual because we have changed our brains and minds to accept that as fact. But that transition from counterfactual to actual, to factual requires a readjustment of the mind.
I just want to ask: Are you implying that the quantum logic uses a kind of 3-valued logic, or is that I don't think I understood.
No, 3-valued logic is much easier to accept. I mean, those logics were developed in multi-valued logic, fuzzy logic, etc. They were all around long before quantum logic. What is shocking about quantum logic is this appearance of X and not X at the same time. So I can send you the physicist's account of that in terms of history. In the course of 2 different strands of history, something can be true in one strand and false in another strand. And you can also see, this is, if you look for Faye Docker on YouTube, you'll find this. And you can see that she's trying her best to articulate this and the audience is struggling. I think in that video, she took nearly 1 hour to kind of come to that possibility in quantum mechanics.
Okay, just to go back very simply to what Mahesh raised earlier, that's where this started. He said, can you have, you have a world with either A or B, you can have A or B. What about a world where you have A and B? Well,
A and B are logically contradictory. Yeah.
If they are logically contradictory, then there is a problem. But if they are not, they can both be there.
Yeah. So I can be a linguist and a father. I can be a father and a son. These are not logically contradictory. But if I say I'm the son and the father of, such and such person, that becomes, difficult because they contradict each other.
So then it becomes, I might be oversimplifying things, then it becomes a matter of convenience, right? I mean, today I could accept one thing because it suits me, and then tomorrow something else suits me and I accept it. And but inherently if I apply logic, then I should believe either A or B. I should either believe fact checking or WhatsApp University. If I believe WhatsApp University today and fact checking tomorrow, that is still in the same world, right? I mean, so isn't it a matter of convenience?
If you say it's a matter of convenience.
For beliefs in particular, for beliefs in particular, I think human beings are able to, simultaneously subscribe to logically contradictory beliefs.
Yeah, see, we all have our own, we live in 2 worlds simultaneously. I don't think that there's anyone who doesn't do that. The rational world and something that's outside the rational world. And so when we have these contradictory beliefs, there could be, so for example, I could believe that ghosts exist in one particular world of mine. But in my rational world, I would have to justify the existence of ghosts, right? So it depends on if you're talking about a single world within a consistent world. And if it's not a rational world, then of course you can have contradictory things.
Also, it is crucial for academic inquiry that your beliefs should be integrated, consistent. It is possible to have two different truths in two different contexts or two different strands of history, but simultaneous, the crucial word for you is simultaneous. They cannot both be true at the same time and space. And that is essentially for Nagarjuna and for quantum mechanics. The moment you abandon that, you abandoning rationality. So it is not a matter of convenience. So opportunism is not allowed.
But Euclidean and non-Euclidean geometry exists in the same world with a similar context,
worlds in the human world. See, mathematicians create their own worlds.
But if you apply Euclidean and non-Euclidean geometry on something being done on Earth, then just the macroscopic view versus microscopic view is what's going to matter.
Yeah.
Now, then it's still the same world, and to Tara's point, it is the same rational world. Yet both these theories are true. So a 8th grader can happily take non-Euclidean geometry and justify, a straight line will intersect other lines at 2 points, and somebody may say vice versa. And you can argue yourself out to say, you know what, yeah, of course I'm considering at a microscopic level. And someone may say, of course I'm considering microscopic level. So I think that's what Mahesh is kind of trying to drive at. It's convenience. I know it's
that kind of convenience.
Dumbing it down in that way, but yeah, that's what he's probably getting at.
No, but at that point, you would have to say, if I'm saying that two lines do meet at two different points, I would have to specify I'm talking about the non-Euclidean world.
Yeah.
Unless you say that there is a contradiction there. Right.
So, okay. So then a fact, if you say, I learned this from the WhatsApp University, and in the WhatsApp University is true, that's a fair statement then, is that right?
Is that a legitimate university?
No, I think that when we talk about principles and axioms, we also need to, if we are specifying the context of application, then there is no contradiction per se. But WhatsApp University, there is no context of application. It is lack of application which makes it a WhatsApp University.
Could I say something?
Sure. Yeah.
About this. So I think that when you take contradictions about different fields together, I think it is important that you have to prove your background, like, or in which context you're giving this information about. So if I'm trying to say that on a spherical surface, two lines can meet two times, I have to specify that on a spherical surface, they will meet. But if someone is opposing me and they say that it will only meet once on a flat surface, I think that it is important that they have to mention the context that they're talking about.
Absolutely.
So when you mention the context that you're talking about, even if they're contradictions, they're still rational because you are not talking about the same field.
Yeah.
Absolutely. Yeah.
Not only that, the moment you bring in the context in where it is true, there is no longer any logical contradiction. So when the quantum mechanics folks say light behaves like a particle under certain experimental conditions, and light behaves like a wave under certain other experimental conditions, there is no logical contradiction here. But the moment you say light is both particle and a wave without specifying the context, that looks like contradiction.
Yeah, makes sense. I had a question on the smell example that you gave, the jasmine flowers. Wouldn't there be formalisms even in phenomenology, the theory of experience? So, if you're experiencing something, then there would be a way to describe that experience. It may be described in form of it's something that comes up as a wish, as a a swish of different smell. It is a sweetish smell, and then it goes away if you are going away from it. But there will be some formalism. I don't know phenomenology formalisms, but I'm assuming somebody would have created something to describe it. No.
The people have tried to describe it in words. People have also, there are three languages essentially. There's a language of natural language of words and phrases and so on, English, French, German, Malayalam, and so on. That is one type of language. And we academics kind of refine that language, make it as precise and rigorous as possible, but they're still using words like field and, and fact and so on, and proof, theorem, whatever. Then there is a visual language, diagrammatic language. So we draw Venn diagrams, two circles intersecting with each other. We draw graphs, branches, and all kinds of things. That's a visual language. And in many cases, the visual language is much easier to understand than the precise natural language. So Bhaskara's proof of the Pythagoras theorem was formulated in the visual language so that people can understand fairly quickly. That is, Euclidean proof is extremely complicated. So if I want to give a proof to a sixth grader, I would use Bhaskara's proof and come to Euclid's proof only much later. Then comes this formal language, which is devoid of all meaning. You just have algebraic symbols. Euclidean, the formal language cannot describe anything in the real world. Formal language cannot describe the smell of the fragrance of jasmine. In fact, in this particular case, you can't even describe it in a visual diagrammatic language.
Kimaya has, I think, Kimaya has something to say. Kimaya has her hand up. Kimaya?
Yeah, Kimaya.
Yes. I had a question based on the example that you gave on classical physics and modern physics. So can we say that counterfactuals, so they become facts based on new data or new evidence? So it can keep changing? Like the modern example, many of us thought that atoms, if you keep on dividing matter, then atoms are the final particles that you get. But there's so many new subatomic atoms that have been found, like quarks, neutrinos. So, like that, the initial counterfactual that there are particles that are smaller than atoms, it has become a fact now based on new evidence.
Absolutely.
So counterfactuals and facts, can we say that this is a connection between them?
Yeah, you're
and
right.
They're connected by data.
Yeah. The history of science has been the history of self-correction. So consider the history of the atom from Dalton to current atomic theory. Dalton held that atoms are indivisible. They are the smallest units of matter. Very soon we discovered atoms are not indivisible. They are divisible. You have this atomic nucleus and then electrons stuck on the atom, like raisins on a bun. And that was revised later, saying, no, electrons are not stuck on the nucleus. They are revolving around the nucleus, like the planets revolving around the sun. So, correction. And then people said, okay, nucleus is not divisible. And then came, the other theory, nucleus itself is divisible. There are these protons and neutrons. And then came the final version of particles, that particles combine to form larger units. At every stage, something that was taken as not true became true when more and more data and more explanations came about. So science Evolution of science is an evolution of is a history of self-correction. We now believe that electrons are not divisible. There is no guarantee that in 50 years that will become true. That the statement that electrons are divisible might become true.
Okay, can I just cut in there and step back a bit?
Huh?
Going back to Kimaya's question, and what you said was when new data comes in and new explanations come in, I think that's what you said. New ways of thinking also need to come in. This is where imagination, new imagined worlds come in. So that's one part of it. The other, now in each of these cases, we've asked what exactly then is a counterfactual in this? When you have a world and you say these are the facts of that world, counterfactual is when you ask, what if this were not the case? Or what if this were possible? So just remember, when you think of counterfactuals, think of it as what if things were different, right? And then start working out for yourself how things might have been different. What would have happened if things were different?
Yeah.
I got the sense that the exact meaning of counterfactual was getting lost here somewhere.
Yeah.
So,
yeah.
Does that make
And
sense?
Tara, in case of that,
Thank
what
you
if?
so much.
Yeah, Chirantan?
Sorry, I just wanted to add, in case of that, what if, then we will also have to think how that what if will affect our existing theory of the world.
Yes.
In whatever.
Absolutely.
Yeah.
Yes.
Yeah.
Yes. If it is related to our world.
Yeah.
Yeah. If you're thinking, because what ifs counterfactuals can happen in the worlds that we create which don't exist, even there, right? So what if that were not the case in that world? When you're writing a story, for example, it could happen there as well. But yes, you have to constantly keep coming back to our world. Otherwise, we don't have an anchor. You're right, Chirantan. Yeah. Kimaya, were you going to say something? Okay.
I just wanted to add. Oh, sorry. Yeah, I guess we're almost out of time.
Wait for a minute.
No, go ahead, Ray. Go ahead. Yeah.
I just wanted to add that when you were describing sort of the revised sort of models of the atom, the last sort of revision you mentioned was the model where electrons are orbiting around the nucleus like planets around the sun. I just want to say that case is particularly interesting because that revision was sort of discarded because of sort of knowledge that was already made, like that was already well known. They realized that that model predicts that electrons would crash into the nucleus based on sort of already known things. So it wasn't new information that led people to discard that model and create the sort of modern quantum mechanical model. It's interesting because they just use predictions from sort of physics that already existed.
And that is also part of the development of science. Aristotle was quite rational in assuming that the earth does not revolve around the sun. And he gave a perfectly rational argument based on his knowledge at that time. And had Aristotle said that the earth does revolve around the sun, he would have been irrational. There were certain kinds of data that he did not know. So he made a prediction on the basis of science as it existed at that point. When a new piece of data came into existence, then something changes. So there are two reasons why science changes. One is data that the old theory cannot explain, or data that is logically contradictory with the old theory. The other is a new theory comes into existence, challenges the old theory, which is the better theory. In the second case, we need imagination to imagine a new theory. So quite often, students are told that science is just a matter of calculations and reasoning and so on. No, science is also a matter of imagination, insight, intuition. The only difficulty is we as teachers don't quite know how to help students develop their capacity for imagination. capacity for responsible imagination, not irresponsible imagination, not daydreaming, not fantasizing. And there are a few ways of doing it, but it is not as easy as developing the rigor, precision, clarity. These are relatively easy. But when it comes to insight, how do you develop students' insight? This is like saying, I can teach students how to draw a perspective correctly, how to be competent in their drawing. But can I help them become a great painter? No way. That is up to them. We can only teach the craft, not the art of science.
Tara Mo, I was hoping you would have a silver bullet on that point. I was just waiting. I mean, this is how you develop insight. I thought you guys would have some sort of magic formula as to how to develop insight. But yeah, it was a bit of a...
No.
There is no magic formula, but if you have a hunch, follow that hunch until you can show that it's not going in the right direction. And you might end up discovering that it is, in fact, an insight. And every time you have that kind of thing, trust it and follow it until you're forced to give it up. There is no other way to, I mean, and then if that's happened, if it happens to you a few times, a couple of times, 3 times, 4 times, that you suddenly find that a hunch was right, then it starts happening on its own. There's no other way. There's no way to develop it in any way.
Yeah.
But this is internal, right? I mean, which is valid. I can get that. But we're at 5-2. I guess I'm taking notes.
Well, we are not very rigid about stopping exactly at 5. The general system that we follow is when we find, how many were we when we started? It's now 18 people. When we find people are exiting, around that time we stop.
No, actually, I think we should. I think it's now we're getting to a point where
I just want to end with something in response to what Mahesh said. This is what I said to John Goldsmith this morning. 50 years ago, I thought I was an excellent teacher. I was very confident and I knew the truth. And that's the way I taught. And gradually, I became less and less confident. Teaching became more and more difficult. So I did not have that feeling that I was an excellent teacher. I was a struggling teacher. Now teaching has become overwhelming for me. And the strong sense, what do I do how do I help the student learn, has become an extraordinary problem. So as you acquire more and more experience, you see your inabilities, your ignorances much more clearly. That was not the case 50 years ago.
It's exactly like saying the more you know what you don't know.
Yeah.
Ignorance is bliss.
Yes.
I would like to make two comments. One is what KP was just saying about teaching becoming a more and more difficult activity. I think we are experiencing that as we progress. But the other point which I wanted to make was that counterfactuals can serve as a very important teaching tool.
Yes.
Because the moment we get into counterfactuals, we also realize interconnections between different things, different propositions, which we may not think of otherwise.
Yes.
So
and
I think
also, that's both in the substance itself, the way of thinking, and also you start constantly asking, what if I had done it such and such way? It would have gone differently, right?
Yes,
it would have had, it would have gone across in a better way. So yes, what ifs are constant in teaching. Yes.
Okay, is that a good time to say amen?
Yes.
Okay. See you guys next week, same time.
Okay.
Wait, hold on for a second. What is the